Hello, it's Keith here, and this is lesson 19 of the Chibiakuams series of my programming tutorials. Now, we've been looking in the last few lessons at how the background is drawn on the MSX2. Now we're going to look at the V990 version because it is different. Now the V9K uses the same tile drawing routine as the regular MSX2, but the gradient routine is very different. It was actually the original prototype gradient routine that I wrote for the MSX2, but the MSX2 was far too slow to actually draw the gradient in this way. But because the V9K is so fast, we can use this less efficient, so to speak, gradient drawing routine, which will do the job just fine, and it does allow more flexibility for the gradients. So how does this gradient routine work? Well, the way it works is we draw a 4 pixel wide and 192 pixel tall strip at the far left hand side of the screen, and this is calculated by the Z80 and it is drawn into this square area using VDP commands. That area is then copied across the entire screen in a single fill command. Now let's have a look at a small example of how we actually do this fill, because it's quite interesting. Now let's imagine that this area here, these purple pixels are the 4 pixels that we've actually drawn on a single line, and this red area is just marking the 4 pixels that we filled in with the VDP commands sending bytes to the area. Now we're going to fill across the rest of the screen, and the way we do this is we specify the source as this kind of area here, and then the destination 4 pixels along, and we're effectively copying data from the areas we've just written. Let me just explain what that means. So when it comes to this pixel here, it will be read from this pixel here, and when it comes to this pixel here, it will be read from this pixel here. This pixel will be written to this pixel, and this pixel will be written to this pixel. Now when we get to the 5th pixel here, we will be reading from this pixel which we just filled in. So this procedure will now continue, filling effectively the entire screen. So with just 2 commands, one being the filling of the 4 pixel area here at the left hand side of the screen, we will effectively fill the entire screen. Now you can see this is sort of demonstrated here. We first fill this tiny little strip here, that becomes a wide strip, and then we draw our tiles and finally our sprites and icons over the top. So that's the procedure that we're using, and the reason this didn't work on the MSX2 is the copy for the large area was just far too slow. The drawing of the tiny gradient strip was okay, and V9K probably isn't really any faster doing that, but it was just far too slow for the MSX2 to do a bitmap copy that's the entire width of the screen, so that's why we couldn't do that. Let's have a look at the actual code that does the work. Now, we've got here an example of the gradient definition that we use for this code. Now, first of all, we need to define 2 lines, and these are the first 2 line pairs that are used. Now the gradient drawing uses 2 alternate line definitions, and each definition is a pair of bytes, which makes up the 4 pixels. So the top 2 lines are a solid color, so all of the nibbles are just D's here. The first line is a special definition, all the others have a constant definition. There is a line number, and this is the line number when we want to change our definition. Then there's 2 bytes, which are the new byte pair that we add to the definition. So the first pair would be this one, and the second pair would be this one. But when the third pair comes in, the first pair is pushed out, so this pair will then be alternated, then this pair will be alternated, very much like the MSX2. And then after that we have, as before, a definition, which is the tick mask, and this is when the scrolling will occur. And as before, we are altering the bytes of the gradient definition here to affect that gradient scroll. We've got the gradient definitions for the top of the screen here, and then we've got the ones for the bottom of the screen here, and there's a 255 to mark the end of the screen. Now we'll just rem that out because that's not actually code that we need here. And here's the start of the definition. Now when this starts, HL will point to the gradient definition and B will be 192 for the height of the screen. Now there are 2 procedures. We're going to use a HMMC to do the filling of the data from the Z80. This defines a small thin square area, and then the bytes that we send from the Z80 will fill into that area. Notice this isn't the same as direct memory access because we're only drawing a thin strip. Then we've got the HMMM, which is the copy command which fills the entire area. So we need to prepare these first, and the most important thing is the memory location of the screen. As I've said before, the screen uses 2 buffers. They will be either Y position 0 or Y position 256. So we're loading that in here, and we're initializing both commands destination Y using that position. Now we load in the 4 bytes of the initial definition that we saw just here, and we're then putting those into the shadow registers B, C, D and E here. Next, what we're doing is we're loading in the scroll line change, and we're storing that using self-modifying code. We're then swapping HL to DE. So now what we're going to do is we're going to initialize the HMMC command. We need to set the destination X to the far left. We need to set the number of pixels to 4. we need to set the number of Y pixels to the height of the screen. We're taking this from B, but in effect it has to always be 192. The HMMC is filling the entire height of the screen, but just a tiny strip. The HMMM is doing the rest of the copy command, but they both need to be the same height. Now what we're doing is we're preparing our HMMC command. Now we need to load in the first byte into the HMMC command. It's rather annoying. This was a sort of thing for the MSX2. The V9K I don't think actually needs it, but for compatibility I do the same for both commands. It was always my intention that I could use basically the same commands for the MSX2 and the V9K. So in this case the V9K version is possibly slightly less efficient, but the V9K always has the speed advantage anyway. Now we wait for the VDP to be ready and we send the command, which will start filling that tiny strip. Of course only the first byte will be written, so now we need to write the rest of the bytes. And this is what we do here. We write the 4 bytes in our shadow registers here to the screen, which will effectively draw 2 lines of that tiny strip. Then we decrease our line count and we see if we've reached a line change or not. If we haven't reached a line change, then we jump away here, but if we have, then we take our tick mask from the ticks occurred parameter, and we then AND it with the current scroll position, which is taken from this definition here. We've then got some self-modifying code here because we need to slow this procedure down for the Turbo R, but these won't do anything on a regular MSX. We then AND in the ticks occurred, and if the result is non-zero, then we're going to scroll these bytes of the gradient. When we get to this point, we've either scrolled the gradient or we don't need to scroll the gradient. What we're going to do now is we're going to load in a new line definition from our gradient definition. So what we're doing is we're loading DE into BC, and then we're loading in a new definition into DE here, and we're doing this from our gradient definition. So we would probably be loading in the second line here if we were going through this. We then load in our new scroll rate and we load in our new line change, which of course will be the next line, the third line. And then we're doing the decrement of the counter to see if we've done all the lines yet. We did another decrement just up here because we are working in pairs here. Now when we get to this point here, we've actually filled that tiny strip at the left hand side of the screen. Now this is something that's quite interesting. Now it worked fine as I've described on the V9K on the emulators, but on the real hardware it did not work. It seems to be that the V9K is buffering a single word of data as it writes to the screen. So when you actually ran the code as I've described it, what you were ending up doing is filling the entire screen with a smear of whatever was in the background already. It wasn't actually doing what it was supposed to. And so what I actually do now is I double the 4 pixel wide strip into an 8 pixel wide strip and then copy it. The buffer is only a single word, so that the 8 pixel wide strip is now 2 words, and this gets around that caching problem that was messing up my theory. So that's what we're doing here. We're setting the source to be the far left, we're setting the width and the destination to be 4 pixels, and so we're copying the 4 pixels and making it up into 8 pixels. Next what we're doing is we're copying that now 8 pixel strip onto the entire width of the screen minus 8 pixels and filling using HMMM, which is the fastest fill command. This has the effect of filling the entire screen with that gradient. So at this point we're actually done and we just return. That's really all there is to it. The procedure is quite simple, and you know, it would have been nice if I could have used this more basic procedure on the MSX2, but the MSX2's VDP is just too slow for a routine like that. Now we've got the shifting routine. It's pretty much the same as we saw in the MSX2 version last time. What we're doing is we're taking the leftmost pixel from the word and we are shifting it to the right, then backing it up. We're then shifting all 3 of the other pixels to the left, and then we're restoring that pixel that we shifted to the right hand side of a byte and we're ORing it in here. This has the effect of shifting all the pixels to the left by 1. We then store it in the correct position in the definition that was passed to us, because of course we are self-modifying the gradient definition here. And that's the version for when we're moving to the right and the gradient's going to the left, but there's an alternate version if we're scrolling in the other direction. Finally, we've got a gradient scroll routine here, which actually controls the direction of the scrolling, because we can scroll left or we can scroll right, or the gradient can be static. This was for the alternate direction scrolling routines, but that's something we're not really going to cover today. Anyway, that's really all there is to it. Hope you found this interesting and maybe it's given you some ideas of ways you can fill the screen more quickly. As I say, this is the easy way for the V9K, but for the MSX2, you're going to have to be quite creative if you're going to have a quite complex animated background, because these, at least in 16 color mode, the VDP isn't very fast. Anyway, thanks for watching today and goodbye.